First of all, thank you. I'm very glad to be here, to be honest, in order to present Brisa, the framework. I know that each hour three new frameworks appear, but I'm going to show you why Brisa is different. I'm Alan Roca, I'm the author of Brisa. Also, I always like to contribute as much as possible to open source. I also built some libraries like Next Translate, that is a library to translate Next.js applications and is used for a lot of people now. It has 80,000 downloads per week. Also, Default, that it's a React state management, Default Composer, among other ones. And now it's time to present Brisa. Brisa, we did the launch this month on October, so it's very, very, very recent. Probably the first question that you are wondering is what kind of web framework is Brisa? No? Because there are different flavors. There are the front-end ones like Vue, Quick, Solid, Svelte, and React. Yeah, now we can consider that React is a framework. It's more than a UI library. Also, there are another pillar that is the backend ones. So here we have Elysia, Express, Hono, etc. And then there are another pillar that is the full stack ones, like Next.js, Solid Start, Remix, Nax, no? That they are using both concepts. So Next.js is using React front-end framework, Next is using Vue.js as front-end framework, and then all the routing part are handled for the framework, so it doesn't use an external framework for the backend part. And well, in reality, there are another pillar that is Astro, but between these three, what do you think Brisa is? Which kind of web framework is Brisa? Mm, full stack. Yeah, Brisa is a full stack web framework, so it's in the same level that Next.js, Solid Start, Next, and Remix. These are some of the features that we are supporting. Only some ones because it's impossible to put here all of them. There are a lot, but probably these ones are the more familiar to you if you work in different frameworks. We are supporting suspense, and of course, with suspense, we are supporting also streaming because suspense without streaming doesn't make sense. We are supporting a CLI to do Brisa dep, Brisa build, also to add some integrations, for example, with Tailwind, etc. You can use this CLI. We are supporting signals. We are supporting partial pre-rendering. So the idea of partial pre-rendering here is a little bit different from Next.js. In an easy way, the developers can specify if some component wants to render on build time instead of runtime, using a prop on the JSX. So we are supporting JSX, also with TypeScript. We are supporting testing matchers. Testing matchers, one of the goals of Brisa is that all the tooling part will be very integrated with the framework. So if you need to test components, you need to use the Brisa tools, and you don't need to add some external libraries in order to do that. We are supporting server-side rendering, also server components, server actions. We are supporting internationalization, not only the routing part, so you also can translate your pages. Here I bring the power of the internationalization library that I was working, because there are a lot of benefits in order to be part of the framework. It's like more smarter in order to only handle the translations that you are consuming in the client code without the need to bring all the dictionary, etc. And also you have more power, like translate your URL path names if you need it, etc. We are supporting a middleware, API routes, clustering, and action signals. Action signals is a new concept. However, is mixing both concepts, no signals and server actions. And the idea of that is that without writing JavaScript client code, you can react the signals on the client things. Okay, now, after introduce you a little bit some features that Brisa are supporting, probably now you are wondering, oh no, is Brisa another React framework? Yes, no. Well, no. Brisa is not a React framework. However, it has a lot of inspirations from React, also from Next.js. And, well, now, probably, you are wondering another question. Okay, if it's not a React framework, then what front-end framework does Brisa use? Because Solid Start is using Solid.js. Next is using Vue.js, and Next.js and Remix are using React. So, what do you think? What front-end framework does Brisa use? Solid.js? No? Okay. Do you think that it's using Vue? No. It's using React? No. Okay. Well, the answer is that Brisa is not using any front-end framework because we are using the web platform. We love the web platform and we are using the web platform as much as possible in order to bring less code as possible and be much integrated as possible to the platform. And for that, for all the client things, we support web component Islam based. And the idea here is that the web components are written in an easy way, like other frameworks like React or Solid. So it's JSX with signals. This is an example of a counter. And however, the idea is to use web components only when it matters. We are supporting also service rendering of the web components with declarative shadow DOM. And we are supporting server components with the idea that it's not necessary to write always web components. And server components, you can write server components in a very similar way that web components. And this is because we bring the web platform to the server. So this means that all the events like on click, on input, on submit, etc., can be handled directly on the server. We mix some ideas from server actions and also from HTMX, and we implement a totally different thing, but we name it server actions. But the goal here in Brisa is that if you want, you can create a single page application without any web component, so without JavaScript client code. And also another goal is to use the hypertext transfer protocol in the HTTP in the same way that it was designed, to transfer hypertext markup language, HTML. And we are using in streaming for all the parts. For the SPA navigation, we are transferring HTML, also for actions, for server actions. This is the bundle size of the client code. We want that all the applications be as tiny as possible. So by default, it's 0 bytes. If you don't add any interaction, it will be a 0 bytes application, so fast. Then, for other scenarios like an e-commerce, for example, that all the interactions are server interactions because it requires a communication to the server to add an item to the cart, or if you need an infinite scroll, etc. All these interactions requires a communication to the server. And the idea here is to use the Brisa server actions that is an RPC that do this communication for you, and it's 2 kilobytes. And the idea is that this is log, so this means that if you have 1,000 interactions in your page, it's not going to increase, it's 2 kilobytes. And however, we are supporting also web components because we know that not all interaction requires a communication to the server. There are some client interactions, and also you need probably to touch the DOM or you need to touch some web API like the local storage, etc. So for these scenarios, we are supporting web components, and it's 3 kilobytes including the signals. So for example, in Preact it's 3 kilobytes, but then if you need the signals, it's another library, so it's bigger. And here we did it in a very tiny size. This is an example of our component, and it's just a counter, the mythic mythic example. But as you can see, it's very similar to other frameworks like React or Solid.js. And the idea here is that we are creating a signal with the state. The initial value in this case is 0, and the count now is the signal. And to consume this signal, you need to put this dot value, and also you can change the value to increase or decrease. And all this is very reactive. So this means that it doesn't have any render, only renders once. And probably you are wondering, well, this code looks tiny, but I know that web components is a class with some methods, and probably this is hard to mangle on build time. And after the build process, probably this code will be massive. And this is the code after compile. So we did some optimizations here in build time. As you can see, we are not using JSX runtime here. We are using JSX build time, and we transformed all the JSX. But the rest of the code is used exactly the same code that the developer wrote. There are some differences, some optimizations. For example, for web components, it's necessary to specify the observable attributes. And here we detect it on build time, and we add a second parameter of Brisa element. And the Brisa element is this 3 kilobytes that has this class with these methods to build this web component. And also it has all these signals. And all this is without minify. So then in production we are minifying, so will be tiny than that. I'm going to introduce a little bit the Brisa architecture. So this is the structure of the source folder. We are supporting pages that is very inspired here with Next.js, how it works in the page router. So for define the routes, is using the file name, and then for dynamic routes is using the same convention than Next.js, and also for the catch-all, etc. And for the API is using exactly the same route definition. So you need to declare some API routes. You can do it in this folder. The difference here is that the prefix of the URL starts with the /API. And then the other one is that in pages you're using an export default, and in the API folder you do unnamed exports with the methods like get, post, or delete, or whatever. We are supporting public for the assets, middleware, layout, WebSockets, internationalization, sitemap. Also, you can create your own folders, of course, components, helpers, whatever. But here an important point is that all these folders, all this code runs only on the server. And the only exception is the web components folder. The web components folder is the only one that not only runs on the server for the server-side rendering, then also it runs on the client as normal web components that they are. This is important because we like the separation of concerns. So the server actions can be only used in the server code. Inside the web components, all the events are normal browser events. And in the server actions, all the events are server actions. So we did this separation of concerns because who likes that? Just client use server, use cache. It's awful. And also, I'm not feel comfortable with that because if I forget use server or the I don't want to bring server code to the client. I want to avoid these mistakes. And I'm not comfortable with that. And this, in reality, was one of the reasons that why I started building Brisa, because I know that server actions matter, are powerful. I like it, but I didn't like how it was implemented in other frameworks. And I wanted to share my ideas to the community. And yeah, more than 1 year ago, I started doing the roadmap that how I wanted to build Brisa, and the first thing was this server actions thing. This is an example of server interaction in Brisa, compared with the traditional way. In order to handle this server interaction, probably you are very familiar with the first image that you need to write JavaScript client code in order to capture the event, then to serialize this data, then to send this serialized data to an endpoint. Then you need to go to the server, create an endpoint, to deserialize this data, do the server stuff, then return a response. Then we need to come back to the client. And in the client, we need to deserialize the data after awaiting the response, updating the state, and then the front-end framework is doing the render. And we wanted to simplify all these things. And in order to do it, we improve a lot the communication between the both walls. So we are adding an RPC client. RPC means remote procedure call, so it's the responsible to do this communication between the both walls. So we add it in the both walls. So in the client, we have an RPC of 2 kilobytes, and on the server, we have another RPC to do this communication. But here, the developers only needs to write this server stuff, and then decide if to do a render or another action that then I'm going to show you the difference. But we can do the render on the server. And this improves a lot the user experience because the users see the changes as soon as possible because we are transferring HTML in streaming. So in the traditional way, if we come back to the traditional way, we needed to await this server response and then do an extra step on the client before the user can see the changes. With Breeze approach, there are two big benefits. The first one is that the client code doesn't increase. So if we don't have a lot of server interactions, will be a tiny application compared with the traditional way. And the second one is that it's using the user experience a lot because the users see the changes as soon as possible. This is an example of server component in Brisa. This is a page, and here we are consuming a server component and also a component. And as you can see, all the code is server code. Here we don't have an import of a client file because the web component is part of the HTML, like a div or another element. So here in Brisa, what we did is to improve a lot the developer experience thanks to TypeScript with TypeSafe, that they can know which web components can consume, also the props, etc. in an easy way. So we recommend that if you use Brisa, you can use JavaScript directly, but use TypeScript because helps a lot in order to consume all this stuff. And maybe you are wondering how we define this selector of this web component. So this selector is based on the name file, on the file name. So this is an example of folder, and in the web component folder here we have two components. One of them is named web component, and the other one is form error feedback. And here there are two things to consider: that the name of the web components it's not a convention of Brisa, it's a convention of web components, how it was to be written. And this convention is that always we're written in kebab case. And the other one is that at least needs two parts to avoid conflicts with other HTML elements like divs, etc. And another thing, sorry, is that all the events works on the server. So as you can detect here that not only the on input, on click, etc. Also the event from web components can be captured on the server, and also the event from server components because we are supporting propagation on the server. And here there is an example, another example of a server component with an input to do some suggestions in real time meanwhile the user is typing. And in order to avoid the number of requests to the server, here we are using an attribute, an extra attribute that Brisa support that the bounds with the name of the event. In this case, to avoid this multiple request. Also, as you can see, this code is server code. So in the server, we can access to the event target value. So you can use the web platform on the server, the events on the server. And then after this action, here there are two different ways. The first one is without any render. This is the concept of action signal that I commented at the beginning. And this is very powerful if you have some web components. To understand how it works, we have two stores. We have one store on the server and another store on the client. So in each wall, we have a different store. However, well, to understand a little bit better, this store on the server only lives in request time. So if the request die, the store also dies. But to improve this communication, we can transfer some properties from one store to another one. And on the web components, this store are signals. So if there are some web components that are consuming the signals, and then you change this store value on the server, and then you transfer to the client, you can react the web components without the need of any render. And then the other approach is using a render on the server, and then you can render the server component, or you can render the page if you need it. And also here the store matters because during the render is in the same request, and then you can consume this store to apply different changes on the JSX that returns this component. And now I'm going to do a fast demo to understand a little bit better these concepts. Give me a second. Okay. So, in order to try Brisa, it's quite easy. You need to write ban create Brisa. Then also we support some flags, like to load some example. I'm going to load this one that it's an SQLite example, and all this code runs only on the server. As you can see, it's very fast. It's a list of movies. These names doesn't make sense. Also the year doesn't make sense. But this is because we are using a SQLite, and let's add some movie, for example, this one. Okay, as you can see, all works like a single page application. Any reload of the page is done, and all is very reactive. I'm going to inspect that. Wait a second. I'm going to add here. I'm going to add another one. I'm going to put a slow 3G to see better how it works, everything. And Armageddon, for example, I don't know the year I'm painting. Take a look. The button is disabled during the action, and then it's added here. And as you can see, not is not replaced all the document, it only replace the part that it changed. So I'm add another one, it's waiting, and boom, now it's adding only this item. And I'm going to change it to fast. Okay, now let's take a look to the code and give me a second to open the code. Okay, this is the code, and remember, it's a page, and all this code runs only on the server. And we have here the form, we have the title, we have the year, we have this button, we have this concept of HTMX also that we are using in Brisa to do this pending state defined on the server. And in order to simulate this disable, because it's a simulation, in reality it's not disabled because we are not changing any state on the client. What we are doing is in the RPC client of Brisa, it's adding this class when you add this indicator, and then with styles you can simulate this disable button, for example. And this is all the code on the onSubmit. In this case, we have access on the server to the event and also to the form data in this case. It's the only event that have some difference because the onSubmit normally doesn't have directly the form data, needs to build this form data. So it changed the event for the form data event, but then it can use this event, for example, for reset the form, and the responsible in order to do this job will be the RPC client of Brisa, but here on the server you specify this job, you insert to the database directly this movie, and then you render the component without the need to do this communication to some endpoint in order to handle that. And now let's take a look to another example. Okay, with example. Okay, this is a simple counter, but this one, all the interaction is in the client, and this one, the interaction happens on the server. And let's see that this counter is a real web component with the shadow root, etc. And it's very reactive. When I change this value, it's only changing this part of the code without doing any render. And here for the server interaction is not replacing all the document, is only changing also this part of code of the DOM, and for each execution is doing a request, and here we are transferring hypermedia, hypertext. And now let's take a look to the code. Give me a second. I'm going to open like this. Desktop with example. Okay, this is the page, and in this case we have the both counters, the web component and the server component one. And as you can see, we only have the import of the server ones, and this is the web component. This web component is very similar to the example of the slides. And if I put now, for example, another property like name, string, and I put it here, for example. Now, if I come back to the page, now thanks to TypeScript, it says that, oh, okay, it's missing the name property. And if I put as a number, oh no, name should be a string. So we can consume all web components without the imports here. We put now Brisa. I can see that the hot reloading works pretty fast, and all this is reactive. So this means that, for example, here now I change to BarcelonaJS. It only changed this part. Let's see again. I change again. Name. It's not replacing all the elements because it's the props are also signals. The only difference is that in props we are not using this dot value convention because they are read only, and this allows to don't break the reactivity in order to define some default properties, also to do some destructuring here on the props. And this is the server counter. It's very, very similar. The only difference is that all this happens on the server. So you put here a console log, increment, and I increment here. As we can see, it's not appearing the console log here because it's executed on the server. And in this case, we are consuming this store on the same component. However, in order to work in the RPC, in the communication between the both walls, we need to transfer it to the client, this store. But then it's just the difference. Here we are changing this counter, and we are doing a render, in this case, of only this element. And okay. And well, it's all. And first, thank you to all the contributors. And feel free to enter to Discord. We are creating a great community there. And also help us with giving an star on GitHub. And thank you also to Senet, that it's I think that it's the only company currently that is using Brisa in production. They are creating a travel agency with Brisa, and also all the back office is created with Brisa. And now feel free to ask any question, and thank you so much.